Hello there. Welcome to Science for High School with Merritt Education Center. The series is for M.2. I am Master Rick, and today we will be talking more about motion, especially on acceleration and momentum. Now, if you're ready to go on a journey with me of knowledge and understanding, then come along. The principle of motion is a complex concept. Now, to further our understanding on this subject matter, there are things that we need to know first. Like the last time that we were here, we were talking about distance and displacement, and at the same time, speed and velocity. We understood those four concepts, correct? Now, today, I have another one for you, and that is acceleration. And we are going to answer that question. What is acceleration? Acceleration is the rate of change of the velocity of an object with respect to time. It is always a function of time. Now, acceleration is a vector quantity because it has both magnitude and direction.
Now here are two important equations that you need to remember for motion. That involves acceleration. For average acceleration, it is mathematically defined as the change in velocity over the time this change occurred. Now for the second equation, it involves the calculation of the final velocity as a vector. It has magnitude and direction, and either variables could change.
Now, I have a question and at the same time a thought experiment for you. Now, if you know me very well, you would know that I am very fond of thought experiments. Now, here is the thought experiment. Let's say you were running on a field and then you suddenly decided to stop. Can you instantly or instantaneously stop your motion? The answer is you cannot, right? Why? Because momentum is in effect. Now, what is momentum? Momentum is just the product of the mass and velocity of an object. It is again a vector quantity, possessing a magnitude and at the same time direction. That is why it is very hard to stop a moving object which is massive than a moving object that has less mass.
Now take a good look at this derivative. Isn't this equation familiar? You are correct. We have been wrestling with this equation from day one of our lesson in force. Now if you recall, there could only be a resultant force if a body is displaced, either moved or put into motion. Now using Newton's second law of motion in deriving our equation for momentum, well denoted here by the small letter p, we arrived at the equation where momentum is equal to the mass of an object multiplied by its velocity. The second law of motion pertains to the behavior of objects for which all existing forces are not balanced. Newton's second law states that the acceleration of an object depends upon two variables: the net force acting on the object and the mass of the object itself. The acceleration of the body is directly proportional to the net force acting on the body, and inversely proportional to the mass of the body. This means that as the force acting upon the object is increased, the acceleration of the object should also increase. Likewise, as the mass of the object is increased, the acceleration of the object should decrease. Now the following would show how acceleration affects us in the real world. Take a look at these speeding cars. If the speed is increasing, the car has positive acceleration. When the car slows down, the speed decreases and is termed as negative acceleration. Now, in both cases, the car is accelerating, but one acceleration is positive and the other negative. And in the case of a person doing a bungee jump, when all of the slack is out of the bungee cord, the acceleration begins to change. As the cord stretches, it exerts an upward force on the jumper. Now here we have two examples of momentum. The first one would show a car and a semi-truck. The car, moving at a relatively fast velocity, has a smaller momentum than the truck because of its small mass, and it will stop much faster. The two football players of equal mass are traveling towards each other. The one moving at the faster velocity has greater momentum and will knock the other one backwards. According to Newton's third law of motion, whenever two objects or two bodies interact, they exert equal and opposite forces on each other. This is often worded, for every action has an equal and opposite reaction. The third law of motion means that for every interaction, there is a pair of forces acting on the two interacting bodies. Here are examples of how the third law of motion operates. In a rocket, burning fuel creates a push on the front of the rocket, pushing it forward. This creates an equal and opposite push on the exhaust gas backwards. Much the same way as walking. In order to move forward, you have to push backward. Here are sample problems to illustrate the laws of motion.
Now here is problem number 1. We will be solving for average acceleration. A car accelerates from rest to a speed of 10 meters per second in 20 seconds. What is the acceleration of the car in meters per second squared? Now, in this problem, the car is accelerating to a speed of 10 meters per second in 20 seconds. To get the average acceleration, you should have your final velocity minus your initial velocity divided by the final time minus the initial time. Now, since the car accelerates from rest to a certain speed, therefore your initial velocity should be 0. And your final velocity should be 10 meters per second. The initial time, since the object is at rest, will also be 0. And the final time should be 20 seconds. Now I'm going to give you a few seconds to solve this problem. And when you finish solving, we will give you the answer. Do you have the answer right now? Do we have the same answers? Very good. For this next problem, we'll be calculating change of momentum. Now the problem states like this. A 5 kilogram mass has its velocity change from 8 meters per second east to 2 meters per second east also. Find the object's change in momentum. Now, in this problem, we need to get the change of momentum. How do we do that? We have the formula for momentum as P is equal to M times delta V, where M is mass and delta V is just the change in your velocity. We have mass as 5 kilograms and the initial velocity is 8 meters per second, while the final velocity is 2 meters per second. All are going towards the east. Now I'm going to give you a few seconds to think about the problem and solve it. Then when you're finished, we will give you the answer right afterwards. The change in momentum here is negative 30 kilograms meter per second east. We all know that momentum is a vector quantity given by the product of the object's mass and the velocity. Now, if the velocity of the object is traveling in what has been chosen in the negative direction, then the momentum would also be negative. Do we have the same answer as negative 30 kilograms meter per second east? Very good. And that ends our lesson on acceleration and momentum for part 2 of motion. Thank you very much for watching and see you in the next episode. And until then, always remember that science is cool.